All right, today we're going to just warm up by rationalizing the denominator. So this is a follow-up. Our last lesson was Unit 6, Day 7, where we talked about rationalizing the denominator. What we mean is we want our denominator to have a rational number, not the square root of something that is not a perfect square. So every single time, our little example the other day was if I had like 3 over the square root of 7. To rationalize that denominator, I would multiply that by the square root of 7 over the square root of 7. In the end, I end up with 3 roots of 7 all over the square root of 7 times the square root of 7 is just 7. So that is me rationalizing the denominator. Okay, 3 roots of 7 over 7 is the same amount as 3 over the square root of 7. Just looks different. So that's what I'm going to do here. So first I'm going to see if I can simplify inside that fraction at all, because this is a lot going on over here, right? 2a squared b to the fourth over 3c, and I want the square root of all of that. We know that's going to be the square root of 2a squared b to the fourth all over the square root of 3c. I didn't see an obvious way to simplify yet. Okay, so now I'm going to take out perfect squares. So a squared is a perfect square. It has an even exponent. And b to the fourth has an even exponent, also a perfect square. So the square root of a squared is a. The square root of b to the fourth is b squared, because I say 4 divided by 2 and pull that out. And I was not able to find the square root of 2, so I still have the square root of 2, just like that. This is all over the square root of 3c. Both 3 and c are under that radical, right? Okay, so I'm going to rationalize. I'm going to multiply this by the square root of 3c over the square root of 3c. So now what I have in my numerator is still a times b squared times. Now I'm going to go ahead and multiply the square root of 2 times the square root of 3c. That's going to be the square root of 2 times 3 inside, so square root of 6c. Over the square root of 3c times the square root of 3c is just 3c. Right? It would be the square root of 9c squared, and when I take those square roots, I just get 3c. So now I want to look and see, is there any way for me to simplify? And I don't believe so. I can't simplify the square root of 6c and regular 3c. I can't simplify those at all. Okay, double check and make sure I can't simplify anything at all. The square root of 6, that is as small as that can be. Square root of c, small as that can be. And I don't have any fractions inside my radical, and I do not have a radical in the denominator. All right, number 2, warming up here. So the first thing I'm going to do is look, can I simplify my fraction at all right now? I don't see a way to simplify that fraction, so I'm going to rewrite this as the square root of 9. Watch this, I'm going to actually write it as y to the 6th times y, because I'm looking for even exponents, so that I'm going to be able to simplify in a moment. Okay, down here I have the square root of 25. Again, I'm looking for even exponents since I'm taking the square root. So I'm looking for exponents that are divisible by 2. Okay, so I broke up x cubed so that it's x squared times x. Now I can see perfect square, perfect square, perfect square, perfect square. So I'm going to take square roots of those perfect squares. So I have 3y to the 6 divided by 2 is 3. And square root of y, I couldn't simplify. This is all over. The square root of 25 is 5. The square root of x squared is x. But it's over the square root of x. Okay, that's getting there, but I have a radical in my denominator, and I'm not allowed to have that. So I'm going to multiply this all by square root of x over square root of x. I'm not changing the amount because I'm really just multiplying it by 1. It's just going to look different. Okay, in the numerator I have 3y to the third times. I'm just going to multiply. I'm using the product rule, and I'm going to put those back together underneath the same radical. Notice I changed the order because we like alphabetical order. Okay, this is all over. 5x times the square root of x times the square root of x. You know that's 5x times the square root of x times x, right? Under the radical. I'm doing this one step by step just to make sure I don't lose you. keep my numerator the same, 3y cubed times the square root of x over y, times the square root of x times y inside the same radical. Now here I have 5x times the square root of x times x is the square root of x squared, right? Square root of x squared. And square root and squared cancel each other out. So I have 5x times x in my denominator. Okay, my numerator is 3y to the third times the square root of xy. My denominator is 5 times x. I undid the square root with the squared, okay? So 5 times x is going to be 5x squared, right? It's okay that I have x squared. I already used my square root sign when I took the square root of x squared the first time. Okay, so that's just my end denominator. Okay, so square root of 24x squared here, all over square root of 3x. I have a couple of ways to look at this. I'm going to imagine that it's all here, 24x squared over 3x. And you may get to the point that you don't feel like you need to rewrite this. If you can notice that 24 divided by 3 is just 8, you can do it that way. I'm just step-by-stepping. So here, 24 divided by 3 is 8. So now under the radical I have 8. And then x squared over x, I say that that is x to the 2 minus 1, so it's just x. Now I need to simplify this, right? So that is the square root of 4 times 2 times x. The square root of 4 is 2, so I have 2 times the square root of 2x as my final answer. All right, thanks for watching.